Next example has a log statement just on one side. Okay, so we have a log on one side and a not a log on the other. So this is where we have to go back to looking at that original, this original conversion. So where we have a log here was equal to x. So remember, the base doesn't change. Okay, so whatever my base is doesn't change, or whatever my base is here would be to this power, and that equals y. Okay, so we're remembering this rearrangement. So looking at this example here, what's my base of this log statement? What's the base? 10. So what could I write here? Remember, we want to try and write it now without the word log.
10 to the power of d. No, one. I don't remember.
So, no. So the Ujma what's it?
No, 10.
All right. So remembering that rearrangement that we were just talking about. Okay. What we're trying to do is use this information here. So we can see that our base here is a. Okay, so we've got this log statement here, and we're trying to change it to be looking like this. So our base here is 10. What would become my power? So in other words, what power did I have to a here? X, yeah, Brianna?
Oh, I was. Never mind.
So we basically, whatever was written on this left-hand side, or the other side, is going to be my power, yeah?
So we have one dollar is doing the answer for A.
We are.
Oh, is that what you're asking?
Yeah. So what would be my power here? Not just 2x. Nice, because everything over here becomes my power.
Wow.
Do you all see that?
No.
So here, right, so I've got log a of y equals x. Right, obviously my statement's here the other way round, but that's okay. But I've got log base of y equals x. That's equal to y equals a to the power of x. So can you see whatever my log statement is equal to becomes my power?
But what is it equal
So what does my log statement equal here? What does it equal? It's not a trick question. What does it equal? 2x plus 1, yes? So that's going to become my power. So I'm going to have 10 to the power of 2x plus 1. And that's going to equal y. Well, y was just this thing here. So that's equal to d.
Oh, okay. Yeah, no.
So I had log base a of y equals x. That translates to be a to the power x equals y. Well, in this case, this is x, this is y, and a secret 10 is my a. So all I've done is rewrite this expression here using those letters. So 10 to the power x equals d. So that could be the end of it. They could take it a little bit further. What do we have?
Wait. Record it. It is.
I am.
No, you weren't.
Yes, I did. Excuse me. So what could we say here? We've got 10 to the power 2x plus 1. So if I had 2 to the power 3 times 2 to the power 4, what would that equal? 2 to the power of 3 plus 4, yes, which is 2 to the power of 7, yes? So what I could do is think about this. If I've got something where I'm adding something, I could try and separate it. So if I've got 10 to the power 2x plus 1, what that actually means is I've got 10 to the power 1 times 10 to the power 2x. You see that? Yeah, so I could separate it like that.
Are we expected you would just take off the 1 and just like 10?
Probably not, but I'm bringing this in just so that you're aware that it could be an option if they have got something that's looking slightly different. So obviously this could be then like 10 times 10 to the 2x equals d. And the d could come over, the 10 could come over here. I'm just making you aware that when we've got powers that are added together, you might be able to separate them.
Simplify that any further, or not simplify, but
Not really, because you've got two unknowns. There's nothing you can really.
You can like use it too because it's dividing. No, it's times it.
What would you want to do with it? You could write 10 to the x is times 10 to the x, like that's, but that's not. Not so much any simpler. Okay. Right, next one. Okay, again, a similar kind of situation. I have an expression here. I've got a log statement on one side. So what we need to do is identify our base. Okay, so what base do I have for my log statement here, Emma?
It would be 10. Sorry.
10. Okay, so I've got my base of 10. What's going to be my power here? Jamie.
The 1.30, like that 1.01 minus the.
Lovely. Oh, that was, can't see my 1 now. Oops. And that's going to equal what? N. Are you with us, Elena?
Yeah.
The other one, she's a bit weary.
Oh.
Yes.
Wait, so even when it's like equivalent, like approximately, like the approximately equal symbol, it's still the same.
Yeah, same rule.
Okay, yeah,
Yeah.
that's why I wrote 10. I was like, wait. Okay, so wait, you think I could simplify it further by doing like it divided by?
You could try that, yeah. In the same kind of principle, you've got 10 to the power 1.3301.
So
Yeah.
if you left it like that.
Yeah, that's fine.
So
I mean, as I say, this one, I was just really drawing your attention to the fact that we've got plus powers. Yeah. There's not a lot of really point doing these. Alright, so the next one, C. We've got lots of log statements all together.
Wait, I had a question about B.
Sorry.
How would you be able to split it up if they're subtracting each other?
So think about the rules when we subtract. When do we subtract?
I don't remember.
Yes, when we were dividing. So we would have 10 to the power 1.301 divided by 10 to the power 2x. You could do that if you wanted to. Okay? Alright, so here I've got all these three things are log statements. So let's see if we could combine them together to make just one log statement on the right hand side. So what would I aim to do first with this right hand side? What's the thing that would be the easiest and best thing to deal with first?
Move the 3 to this as a power of B.
Nice, so we can deal with this and it's going to become a power. So we've got log C equals log A plus log B cubed. And then our laws of logs tell us that we would then combine these two. So we would have log C equals log of AB cubed, because that's our laws of logs. And then what do you think I could say about C on its own? Yeah?
C equals AB2.
It's a secret 3, but yes.
AB3.
Yeah.
I just thought it was 2.
Because if this is log of this, and this is log of this, it must mean these things must be equal to each other. Yes? So essentially what we're doing is we're kind of de-logging. Okay, so you can unlog something.
What about the 10? Yeah.
Because they're both base 10,
Oh,
that's
okay.
why we can do it. If they were different bases, we wouldn't be able to.
Wait, so why couldn't we do it? I'm still stuck on A. Why couldn't we do it on A?
We started off with that original. We ended up with the
Oh my
log
gosh,
statement.
sorry. I'm sorry. Oh, that's stupid. Okay.
Alright, so here's one of those situations where we've got a log here, that, we don't have a log here. Remember, what do we do to try and make this thing here a log statement? What log statement would we have that would end up with a 1? Elena?
It will be like log 10 to 10.
Nice. Okay. So I would have log G equals 2 log D minus log. Are we all happy that I just write log 10? Because secretly we know our base is 10. Yep. So 1, remember, becomes log 10.
Can we write in the 10?
If you wish to write in the 10,
Will
of
we
course
write
you
it?
You officially then you should be writing them in all of the positions. So Kiara, what's my next plan of action? What should I deal with next, do you think?
When you simplify the 2 log G into log 10.
Not yet. The reason being is because I don't like that big 2 where it is.
Oh, you make the D squared.
Nice. Okay, so this big 2 is going to become a power. So I've got log G equals log D squared minus log 10.
Would you divide them?
Not yet. We only de-logged when we had one log statement equals one log
okay.
statement. So Dinah, what's my next plan of action? How would I join them? Remember that we've got a one log statement, subtract another log statement. Yeah, what would I divide? Nice. So I would have log G equals log of D squared over 10. Doesn't necessarily have to be in a bracket. I've just put it in a bracket to keep it together.
You would just put 10.
Yeah, you would just put 10.
Mm.
And at this point now, because we have log statement equals log statement, we can delog it. So it becomes G equals D squared over 10.
If we just wrote like before G equals D squared subtract 10, would that?
That would be wrong.